Okay, this video is about how to do multi-step mole problems. So these next few problems are going to be more than one step here. So the question is, first one, how many molecules are found in 4.8 grams of water? All right, so first step is to write down what the problem gives us. 4.8 grams of H2O. Now if we look, the only thing that we can change grams to would be moles. But the thinking is if we can change grams to moles, then we can change moles to molecules. So what we're going to do is first change to moles. So we're going to go in 1 mole H2O. We're going to do the molar mass of water. So 16 plus 1 plus 1 is 18. That's 18 grams of water. So I just did the molar mass there. Kind of did it quickly in my head, but that's how you do it. And then the next thing is, so I've changed, if I stop right there, I've changed to moles, but you don't want to stop the problem. You just want to keep going. So you want to look at the next conversion factor. Now we could use any of these three with moles in them, but we want the one that goes to molecules. So we're going to choose the top one. So we're going to say for every 1 mole water, there are 6.02 e to the 23rd. Now you got to make sure you pick the correct label, atom, molecule, or formula unit. Well, remember water is like H2O, kind of looks like that. It exists as a molecule. So you can actually label this molecules. And then, since that's what you're looking for, that's when you stop the problem. Then you do the math here. So now on the math, you would take 4.8, and then I just go all the way across the top. I just do all the math on the top and then all the math on the bottom. So times 1, or you can skip that since it doesn't really matter. But then times 6.02 to the 23rd power. Then I'm going to divide by everything on the bottom. I'm going to divide by 18, and I'm going to divide by 1. And so I end up getting this answer, 1.605 e to the 23rd. This has 2 significant digits, so I'm going to round it off to 1.6 e to the 23rd molecules water. Okay, let's try another one of these. Okay, so this one says how many atoms are found in 4.8 grams of water, and so I would like you to compare this one. Okay, so this one we're asking for how many atoms. The one previously was asking for how many molecules. Okay, I want to show you the difference here. Okay, so step number 1, you write 4.8 grams of water. Okay, the only thing that you can change water or grams into is moles. So for every 1 mole of water, you use the molar mass, that's 18 grams water. Okay, now we want to go to atoms, so we're going to use this top one up here. And we're going to go 1 mole of water equals 6.02 e to the 23rd. But you got to think about what is water. Water is H2O. Okay, it's not an atom. It's a collection of atoms called a molecule. So you can't call it an atom. You can't call water an atom. It's made up of atoms. So there's that many molecules. Now we got to do one more step. And we're going to use this bottom one right here. For every 1 molecule of water, there are how many atoms? You would just count. There's 1, 2, 3. 2 hydrogens and 1 oxygen. There are 3 atoms. Okay? And so then you would do the math here. So like I said, I like to do everything on the top first. So 4.8 times 6.02 to the 23rd power times 3 divided by 18 divided by 1 and divided by 1, which we could just skip that. So I end up getting 4.816 e to the 23rd, which I'm going to use. There's 2 significant digits at the beginning, so I'm going to round 4.8 e to the 23rd, and that would be atoms. Okay, notice the difference between this one and the one before it. Okay, we were going to molecules of water, so we could say that 1 mole of water is 6.02 to 23 molecules. But when we want to know atoms, we have to do one more step. Okay, here's a couple other problems I'm just going to work through here. So they're multi-step ones. So how many grams are in 3.5 liters of hydrogen at STP? So write down what the problem gives you. Remember that hydrogen is H2. It's a diatomic substance. So 3.50 liters of hydrogen. The only thing you can change the liters to are moles. See, there's only one conversion factor with liters in it. So for every 1 mole of H2, there's 22.4 liters H2. Notice the principle of diagonality, how I'm keeping the liters diagonal from the liters. Now, I want to go to grams, but I'm in moles. Is there any conversion factor from moles to grams? Yes, there is. So, for every 1 mole of H2, then we would have to use a periodic table and look up the molar mass of hydrogen, which is 1, but there's 2 of them. So that's 2 grams hydrogen. All right, moles cancel, and we're in grams. We know to stop the problem. So we do all the math on the top first. 3.5 times 1 times 2. Divide by everything on the bottom. Divided by 22.4, divide by 1. And so I get, with the calculator, 0.3125. We have 3 significant digits. Always count a trailing 0, and there's a decimal point in the number. So I got to have 3 significant digits here. So it's going to be 0.31. That 5 makes the 2 a 3 grams of H2. Okay, let's do one more problem here. How many grams are in 4.5 liters of helium? So 4.5 liters of helium. We draw the picket fence. Okay, the only thing you can do with liters is change it to moles. 1 mole helium is 22.4 liters of helium. I use this conversion factor right there. I knew I had to use that one because I started with liters. I went to moles. Okay, now I'm going to change moles to grams. 1 mole helium. Then you use the periodic table and look up the molar mass of helium. And it's around 4 grams helium. Okay, I know to stop because I'm at grams. So 4.5, let's do the math. Everything multiply of everything on the top, divide by everything on the bottom. So 4.5 times 1 times 4, divide by 22.4, divide by 1. And my calculator says 0.8035, something like that. This only has 2 significant digits, so I'm going to round to 2. So 0.80